Alright, today we're going to prove that the diagonals of a parallelogram meet at right angles if and only if it's a rhombus. Now, I want you to remember that when we see the words if and only if, we've got a two-way street, and so we're going to need to prove both cases. Okay, so we're going to have to prove forwards and backwards. So our first case is going to be, well, given that the diagonals meet at 90 degrees, then this shape must be a rhombus. So to prove it's a rhombus, well, we have to have our adjacent sides are equal in length because it's already a parallelogram. Okay. Our second case is, given that this is a rhombus, then the diagonals must meet at 90 degrees. All right, let's start with a parallelogram. So let ABCD be a parallelogram. Okay, and we are required to prove that if diagonals meet at 90 degrees, then ABCD is a rhombus. All right. Remember that for lines that are perpendicular to each other, our dot product is equal to 0. So we're saying that the diagonals do meet at 90 degrees. So since DB is perpendicular to AC, our dot product is going to be equal to 0. Okay. Here's our proof. Let's have a look here. To get DB, I go minus AD plus AB. So DB is equal to minus AD plus AB. Okay. And to get AC, I'm going to say AB plus BC. Okay, but ABCD is a parallelogram. So therefore, BC, if I have a look here, BC is equal to AD. Okay, so therefore AC is going to be AB plus AD. All right, let's have a look at our dot product between DB and AC. So DB dotted with AC, we've already said is equal to 0. So this means that I have AB minus AD dotted with AB plus AD is equal to 0. And I can expand that. So I'm going to have, remember that AB times AB becomes the absolute value of AB squared, or the magnitude of AB squared. Then I have plus AB AD dotted with AD minus AD DAB, and then I have minus AD squared, and that has to equal 0. These are going to cancel, and then I have that my magnitude of AB squared minus my magnitude of AD squared equals 0. So therefore my magnitude of AB squared is going to be equal to my magnitude of AD squared. So therefore AB is equal to AD. Now those are adjacent sides. There's AB, there's AD. So if those are the same length, this is a rhombus. So therefore, if adjacent sides in a parallelogram are equal, then the shape is a rhombus. All right, so we've proven case 1. Oh, we should probably write up here case 1 so that we know we've got 2 cases. Let's have a look at case 2. Now, case 2 says, if this is a rhombus, then my diagonals meet at 90 degrees. Okay, so here we are required to prove that if ABCD is a rhombus, then AC is perpendicular to DB. All right, so let's do our proof for that. Now we've been given that this is a rhombus, so we know that our magnitude of all 4 sides is the same. So let's say that since ABCD is a rhombus, I know that the magnitude of AD is equal to the magnitude of DC is equal to the magnitude of CB is equal to the magnitude of BA. Okay, and if I took the dot product of my diagonals, so AC dotted with DB, so AC dotted with DB, well, I've already set up before that I can get AC is going to be AB plus BC. Oh, hang on, the other one, AB plus AD. And my DB was going to be AB minus AD. And if I dot those, I'm going to end up with the same as I had before. So my magnitude of AB squared minus my magnitude of AD squared. And I know I've been given that AD equals AB because it is a rhombus, okay? And I've got these squared magnitudes, but because I know that the original magnitude is the same, my squared magnitude is the same. So I can say, since AB, the magnitude of AB equals the magnitude of AD, my magnitude of AB squared equals my magnitude of AD squared. So therefore that's AB squared minus AD squared is equal to 0. And if my dot product is equal to 0, AC is perpendicular, that's a C, to DB. Okay, so therefore I can say the diagonals meet at right angles if and only if it is a rhombus. Doesn't like my handwriting.